All right, let's do this beast. All right. There's very few things I make you memorize in here. Okay, there's some. This is the unit circle. Remember, you just need to develop it. You need to memorize it. Although knowing it helped you on that practice exam a lot, actually. There's about 4 questions I know were knowing the unit circle. Wow. That gets you pretty close. All right. So, reciprocal identities. You need to go into the test knowing this. Okay? You need to know that cosecant is 1 over sine. You need to know secant is 1 over cosine. You need to know cotangent is 1 over tangent. There was 2 or 3 questions on the practice exam where knowing that was beneficial, especially when you came to the identities, which we'll talk. This is going to be huge. You also need to know tan is sine over cosine and cotan is cosine over sine. Those are ones we've talked at ad nauseum, but it's very important, especially in this unit, to know that. Cotangent is cosine on top because they're both co. That's the trickiest one to remember. Okay? Now what we're going to do is we're going to manipulate. Why are we doing this? We need to be able to manipulate trig functions to get them all in terms of like 1 or to change it to something we can deal with. Like in basic math, there's more than one way to get to 7, right? So you can do 2 plus 5 or 3 plus 4. Maybe 2 plus 5 are 2 trig functions you can't deal with, but 3 plus 4 is. You'll see what we're doing. You maybe will see. Here's some other ones that you have to memorize. Okay? Now I say that, honestly, there wasn't a single question with this on the practice test, which really, really disappointed me. But sine squared plus cosine squared is 1. And that is because on my unit circle, what's the radius of this? 1. And this is my x and that's my y. So what's a squared plus b squared always going to be on the unit circle? C squared, which is 1. So sine squared plus cosine squared is 1. No matter any angle x, any part in the unit circle, if I squared my x and my y and add them together, I get 1. These two don't come as much. If you are going to take calculus, you absolutely need to know these 3. These are 3 things that you use a lot in calculus. Okay? Because when I taught AP Calc back in the day, we use these all the time because sometimes a derivative's easier, like we need to get rid of a constant. You'll see why if you take calculus. Now this one looks scary, but it's not. Well, it's kind of scary. Oh, remember when we learned how to factor, y'all? Alright, here's what I want you to think about. What's true? If I have a negative x, that's negative, right? Because what kind of function are these? Those are odd, right? And remember with odd function, this is a throwback to a long time ago. An odd function means f of negative x equals negative x, right? So isn't that just saying that these are odd? So if there's a negative inside, I can move it to the outside. Again, I didn't see a single problem in the practice test that used this one. There was one with a double angle formula. I don't remember any of the even odds ones. But there might have been one. I could be wrong. I'm wrong a lot. But you didn't have to agree so vigorously. But this is good to know for any odd function, right? Like x to the third. If you plug in a negative, the whole thing is negative. What are the other functions then? Even, because with an even function, again, this is a nice review of definition. F of negative x equals, oh, I should put this, positive f of x. Because what's negative x squared? X squared. So what's cosine negative x? Cosine of x, because I can flip it. I wrote this wrong, I'm sorry. That'd be negative f. That was from a long time ago, but it's good to review it. They didn't ask if to prove any even odd either on the practice test. They actually skipped. The test was shorter than I thought, and we've covered a lot, so they skipped a lot of stuff, actually, which makes me nervous. But we're going to do 2 more practice tests, which will help. All right. So, know which ones are... What do all these have in common? That's cosine, cosine, right? Secant is 1 over cosine, so these go together. And then we have sine and 1 over sine. So these are the same thing. These ones you just have to, honestly, there's no correlation on ones. Just know which ones are even. Think of the graph. Which one do you reflect on itself? Which one do you rotate? If you rotate on itself, the negative moves in front. If it flips on itself, the negative goes away. Okay? I wish I could go into, I have a proof to why these work, but no proof, not a single proof on the, that's one thing you guys are looking out. Normal pre-calc, I spend about 3 weeks on proofs of trig identities. But the AP exam, there's no proofs of trig identities. It is actually. That is one thing that is easier. Yeah. I wonder why they don't do proofs of it. I guess you don't need it in calc to do the proofs, but they're pretty interesting, actually. What? That was the second highest test score. I just looked at it the other day. I don't know why people think they do bad on it. All right. Look at this. Now we're going to prove a basic identity. We're going to prove it to, we are going to prove it so it helps you memorize it. And this is a really common, important one. So if I take this and I draw a right triangle in, and this is a coordinate plane with the point x, y, right? You agree? So this is my x and this is my y. What kind of circle is this? Oh, this is a unit circle. If I call this radius 1, what does x squared plus y squared have to equal? 1. Pythagorean theorem, right? Again, visualizing this can help. It's hard to memorize. It's easier to understand. In the unit circle, what is my x coordinate? It's my cosine of this angle, right? Cosine is my x. Sine is my y. Do you agree on that? So what can I plug in? What can I plug into these to get my first identity? I can plug in cosine squared plus sine squared equals 1. You see what I did there? Pythagorean theorem. Now watch this. I'm going to give you all 3 identities with 1 proof. Let's do another identity. Watch this. This again, these are the old, oh, Jiminy Crickets, that's grody. Alright, so let's do this. What if I divided everything by cosine squared on this one? Just think about this. I'm going to divide this by cosine squared. What's cosine squared divided by cosine squared? 1. What's sine over cosine? And what's 1 over cosine's identity? Secant. Wait a second, Mr. Twilliger. That's the other identity I told you to memorize. It's another Pythagorean. How many steps was that proof? These are the proofs that we would do. They're like plugging in stuff. Now, do you guys think I can prove another one? Watch this. Watch, this is going to blow. Let's do the last one. So I'm going to start with something I know. I know cosine squared plus sine squared is what? 1, right? What if I divide everything by sine squared? What's cosine over sine? Cotan, right? Sine over sine is 1, and 1 over sine is cosecant squared. So those are my 3 major Pythagorean identities. And it all comes from the fact that a squared plus b squared equals c squared. That's it. That's all. Okay. Hey, this year's geometry had a 92 average on their trig test. You guys had a 68. Jeez. All right. You did have a question like this on the practice test, and I'm going to let you know right now. These look really scary, but they're not. What I do anytime I see a problem that says simplify the trig ratio and they're all not squared, I'm going to convert them all to cosines and sines. Okay? So what I mean by that is cosine is just cosine, right? Can I convert tan into sines and cosines? Yeah, that's sine of b over cosine of b. Those are b's, betas. So you have a cos b, e. Shouldn't that one be in jail? What? Get it? All right. Well, that's why the sin's there. All right, so I digress. All right. So let's prove it. I can't believe you guys said that. All right. Hey, what happens to my cosine b, my cos b? They get canceled. They get canceled. And what's left was sine or... Anyway. That's it. I just proved it. Does sine of b equal sine of b? Yeah. That's a proof. You guys just did a trig proof. Are there some where it's like, no? Yes. Sometimes they don't work. But I don't know if you'll see that in the AP test, actually. If you're using multiple angles, you'll see, if you go into physics, there's alphas and betas in a lot of different problems. So there's actually alpha, betas, thetas. Psi comes up too sometimes. But it just means, it's getting used to that notation because you see it sometimes in calc. They'll use beta. Now let's do this one. So on the test, what they would do is they'll give you that and they'll ask you to simplify it to one trig term. And the reason we want to do that is if you're doing calc, graphing one trig thing is easier than graphing multiple. Does that make sense? So let's simplify this one. Sine becomes sine. What's secant? 1 over cosine, right? And that I need to get that to look like tan of x. Well, that becomes sine of x over cosine of x, which is tan of x. Yeah, because if this was a multiple choice, it would just tan of x would be one of your answers. So, you know what I mean? Because they want to be one trig function, so they're looking for you to get done. They won't ask you, I've never seen a question that says verified because this would be on the multiple choice. You know what I mean? So multiple choice will just be like convert that and write it in terms of one trig function. And it'd be tan of x when you get done. You know what I mean? That's what you'll have to see. Now, if you have to take a class with proofs, then you have to keep going and get it all the way to the end. But you don't need to do a two-column proofs aren't real. They don't exist in mathematics. You do linear thinking because you're writing it for mathematicians. So like you don't have to say because, it's well known. Like this is established. If you're using theorems and formulas, you can just do it. All right, let's do this one. Look at us go. All right. Again, rewrite this. The question you might see is rewrite this to make it look like this. Okay? This is actually, it looks like it's going to be trig. This, you can't. You can only manipulate one side because they would do this. Oh, I know it. I'll show you. So I'm going to try to make this look like sine squared. But pretend like if this multiple choice, you're given this, write it in terms of one trig functions our goal. That's too many. Taking the derivative of that is yucky doo-doo. Sorry for the language. So with a fraction, what can I do with this? Can I rewrite this as sine of x over cosecant of x minus cosecant of x over cosecant of x, right? You guys see what I did there? It's like if I had 1 plus 3 over 4, I could do 1 over 4 plus 3 over 4. You know what I mean? Break into pieces. Well, this one I have to because I can't. You can't just cancel that, right? It has to hit both. What's cosecant over cosecant? 1. Now, what does Mr. Twilliger like to do whenever he sees it? I'm going to write it all in terms of sine and cosine. That's always my first step. Sometimes there's easier ways, like less steps, but I'm going to tell you right now, this way always works for trig. If you term all sines and cosines, you will get where you need to go. So I have sine over 1 over sine. I'm dividing by a fraction, so I multiply by the reciprocal. So what's sine times sine? Sine squared minus 1, right? Does that look like my right side?
Yeah.
Did I get down to one trig function? Yeah, because that 1 is not a trig function. Like, you know what I mean? You can have numbers with it. But my goal is to get this down to one trig function. This one, they didn't do that. What? That? This is work is your answer. Well, no, like on the test, you wouldn't have that side. They're like, rewrite that as a one trig function. You know what I mean? And a lot of people would freak out with that -1, but that's allowed, right? That's not 2 trig functions. That's a constant. This one's a little bit different. This one they're asking me to verify. So this one's going to get real dicey. All right, we got to make this look like that, right? Or it might say, here's the test question. Take this, and which of the answer choices is equivalent to this one, right? What does Mr. Twilliger do every time? That's not what they did, but that's what I'm going to do because that's how I roll. So I'm going to do 1 over cosine squared over, what's tangent? Sine over cosine, right? A lot of fraction work here, guys. I'm going to do it. What do I do? What do? I multiply by the reciprocal, right? This is the same thing as cosine of x over sine of x times 1 over cosine of x, right? Oh, wait, there's a squared. Abomination. What happens to one of my cosines? They cancel. So this becomes a 1, right? What's 1 over sine? What's 1 over cosine? Did I get him? Also, did you guys, if you look at your scoring guide, they never rationalize their denominator, so you don't have to in this. Like if you have 1 over square root of 3, you can leave the answer as 1 over square root of 3 for pre-calc. It's verified now. I looked into it. You do not rationalize denominators. That you never will have to do that again in your mathematical life, actually. It's just a high school thing. It's not an actual thing. Isn't math fun? Alright, I can do this. Whew. Alright, y'all. Guess what we're doing again? Same thing. Alright, again, let's pretend like this says, rewrite this as one trig function. How scary does that look? Very scary. But watch, what if we change everything to sine and cosine? You think it's going to work out really well? Let's do it. Is sine squared becomes sine squared. Secant becomes 1 over cosine, right? And cosecant is 1 over sine, right? So again, it looks, don't let these identities get to you, because I'm going to assure you that they work out way better than you think they're going to. You know what I mean? Like, that looks scary, but so far, has there been anything too wild that we've done? No. What's a sine divided by a sine? How many of them cancel? So what am I left with? Yeah, right? It's just fractions. And sine over cosine is? That's not so bad. Let's do this. Yeah, let's all just get jobs. What? That's not. Focus on what? 3 wins. No, I think they're going to end the year at like 490 winning. I think they're going to be just sub 500. But I think they're going to be, I think next year they're going to be very competitive, actually. They need 1 or 2 veterans to sign. You know what I mean? Like, they have a few holes in their lineup, and their pitching rotation's bad. Bullpen looks good. A lot of young talent. They look good. White Sox are bad, though. Take that, Chicago. All right. What do I do first? Convert everything. Now, what's nice about this is when you start doing this a lot, like tan of x, you're just going to see that sine over cosine. Like, that's what I do whenever we've been doing this. That's what I see it as. Like, in my head, I'm like, sine over cosine. This one's going to get a little bit dicier, okay? But do you all agree with that first step I did? What's sine times sine? Now, why can't I add these together yet? What don't they have? They don't have a common denominator. So what do I have to do to this side to make it so I can add to this side? I have to times it by cosine over cosine, right? Again, there's a lot of algebra actually in this, but I need a common denominator so I can combine them, all right? What is cosine times cosine? Cosine squared. I want you to stop for a second and look at this. Is questions why I did that. Now, if they have the same denominator, can I combine the top? Right? Now, according to my identities that we proved with the Pythagorean theorem, what is sine squared plus cosine squared? 1. And 1 over cosine is secant. So why do we need to know this? If you are in a class and you have to take a derivative of that, it stinks. Taking derivative of that's easy. It's 1 over tan squared, I believe. No. Uh-oh. No, secant squared. No, I did that wrong. I haven't taught calc in, I think, like, I think it was 9 years ago or something. All right, one more exam. Do we have time? No, we don't. We got 3 minutes. We got time for this. Watch this, y'all. It's going to take me no time at all. Remember, what's your homework tonight? Grade your practice test. Come in, right? This one's going to be fun. All right. Is this already in sine and cosine? It is, right? Did I skip one? What do I need to actually combine these? Common denominator. So we'll multiply by cosine of x, cosine of x. And what do I multiply by over here? 1 minus sine of x. Do you guys see what I did? Common denominators. What's cosine times cosine? And then this is going to become cosine of x minus I don't want to actually FOIL it out. I'm not going to. You can't tell me what to do. Only my kids and my wife tell me what to do. Do you agree on that? Minus, this top part is going to be sine of x minus sine squared of x all over that cosine sine, right? Not going to make it. Yeah, I will. Subtract positive, positive, right? So this becomes cosine squared plus sine squared. I'm losing the x, brother. Minus sine of x, right? Hold on, watch this. No, just stop it. I'm doing it. The bottom's cosine of x times 1 minus sine of x, right? What's cosine squared plus sine squared? What's cosine squared plus sine squared? What's cosine squared plus sine squared? So that's 1, right? I have 1 minus sine of x on the top. What happens? What am I left with? What's 1 over cosine? Sorry, I did that one really fast. But I did it.
You should pick a different color.